Hey guys, so today we're going to be talking about inverse functions. And so you can see that the learning target for today is I can find the inverse of a simple function by solving for y. So we're going to focus on simple, more simple equations and functions, though you can use these steps technically to solve for any inverse. So let's all first think about what is an inverse function. Let's think about inverse operations, something different that we know inverses with. So what is the inverse of addition when you're thinking about inverse operations? Hopefully you just said to yourself that it's subtraction, but I want you to think about why. Why is the inverse of addition subtraction? Hopefully you just said that it undoes subtraction. So for example, if I have 2 minus 2, a pot plus 2 minus 2, that would give me 0. So that undoes the addition or the subtraction. How about the inverse of division? What's the inverse of division? So your inverse of division, you should have said to yourself, is multiplication. But again, why? Why is that the inverse of division? Well, if I have something that I'm dividing by 2 and then I multiply it by 2, that gets rid of the division, or it's the inverse of the division, because dividing by 2, multiplying by 2 gives me 1, which when I'm multiplying is that's what I'm trying to get for my inverse function or inverse operations. So as you go through this video, anytime something is written in green like this, that's something you definitely want to write down in your notes. So an inverse function is a function that undoes the original function. So if I have, so similar to inverse operations, addition and subtraction undo each other, multiplication and division undo each other, squaring something and the square root undoes something. An inverse function is when I have an entire function rule that undoes the original function. So for example, if I have f of x equals 3x plus 2, I'm multiplying my input by 3 and then adding 2. So the inverse would be f inverse of x. We'll talk more about this little -1 here in a little bit, but f inverse of x would be x minus 2 divided by 3. What do you notice about these two functions? Just say something to yourself. Maybe circle something on your paper about what you notice about these two functions if I tell you that these are inverse functions. So a couple things you might notice. You might notice that there's a plus 2 here, there's a minus 2 here. So I notice that inverse operation. I see multiplying by 3 and dividing by 3. That's an inverse operation. You also might be wondering what this little -1 is when I have the f here and the f -1 there. We'll talk about that in just a couple minutes. So let's talk about how this works. So if I have my function f of x equals 3x plus 2, what that rule tells me to do is to start with my x and to first, if I'm moving through function f, to first multiply by 3, which is where I get that 3x, and then add 2, which is where I get my 3x plus 2. So if I'm working through my inverse function, which is where I get this -1, the little -1 means inverse. So this is f inverse, or the inverse of function f. What that means is to move in the opposite direction, to undo what we just did here. So first, if I added 2 before, starting from 3x minus 2, I would want to subtract 2. That would get me back to my 3x. And then divide by 3, which would get me back to the x. And so when we write out in this order what this would look like, this is where we get our f inverse of x equals x minus 2 divided by 3. And again, this is the way we write inverse function notation. You want to write this down. Anytime you see that -1 here on your function notation, that tells you that it's an inverse function. So this is generally that was generally what an inverse function is. Let's talk about how we find the inverse of a function. So here's the nice thing. You already know how to do this. If you can solve an equation, you can solve for an inverse function. So the first thing we want to do is to replace the f of x with y in the equation for f of x. So the reason we want to do that is because it just writing f of x gets really messy, but we know that f of x just means output and y means output. So we can just switch those two. So the f of x is the same thing as the y. Then we'll switch the x and y. This is our key inverse step right here. Once we switch the x and the y, that is where we are kind of creating our inverse. Then we don't like equations to be x equals, we like it to be y equals. So then we'll solve that equation for y using your inverse operations. And finally, we will replace the y in step 3 with our f inverse of x notation. So we're going back to the function notation. Later on this next week, you will learn how to verify two functions are inverses. Today, we're just going to work on finding the inverse function. So let's use these steps. So we're going to start with the function f of x equals x plus 7 divided by 4. So my first step told me to change that f of x to y. So literally, you'll notice all I did here was take this f of x and write y. And then switch my x and y. So now instead of y equals, I have x equals y plus 7 divided by 4. And then step 3 is to use my inverse operations to solve. So I would want to start by getting rid of the 4 in the denominator. So I'd multiply both sides by 4, which gets me 4x equals y plus 7. And then I want to subtract the 7. So y equals 4x minus 7 would be my inverse function, but I want to write that in function notation. So I use my f inverse of x equals 4x minus 7. And this would be my inverse function. So again, once we get to the step of switching x and y, we're just solving for this y. We're trying to get that y by itself using our inverse operations. So I want you to take a moment and work through this problem, finding the inverse of g of x equals 7x minus 5. So pause your video, work this out in your notebook before moving on, and in a moment I will pull up the correct answer, but make sure you've paused the video until you've worked it out. So you should have gotten that your g inverse of x is x plus 5 divided by 7. If you didn't, pause here and ask a table partner to help you work through this. What about this one? Let's look at this one. So find the inverse of the function f of x equals x to the third power plus 1. So don't overthink this. We're still going to work this out exactly the same way. We just have some different inverse operations that we're going to have to work with. So first I want to change that f of x to a y. So I have y equals x cubed plus 1. And then my next step, which is where I create my inverse, is to switch the x and the y. Notice I only switch the variables. I don't switch any of the operations. So now I have x equals y to the third power plus 1. And now I want to solve for this y. I want to get the y by itself. So I would start by subtracting the 1 from both sides. And then let's think about what the inverse of a cube is. You may or may not have an idea for this one, but the inverse of a cube is a cube root. All this does over here with my y, all this will do is cancel the cube and the cube root, and I leave my cube root of x minus 1 on that left side. So I get the cube root of x minus 1 equals y. And if I'm turning that back into my function notation, f inverse of x equals the cube root of x minus 1. So again here, all of the steps are the same. I just need to use a different inverse operation. So at this point, what I want you to do is grab one of the pre-calculus textbooks. They're over by the windows. They should have a hot pepper on the front. They say pre-calculus. Turn to page 240 and 241, and I want you to complete these problems 11 through 20, 21, 23, 25, and 27 by finding the inverse. Don't worry about verifying them yet. We'll do that next week. Just to note, the answers for the odd problems are on page AA16 in the back of the book. Anything you don't finish in class, go ahead and take a picture because this will be and is your homework for next Monday. Before class ends, make sure you've returned your books to the shelves, put away your computers and your calculators, and just make sure the classroom is ready for the next class period.